I know.
All right. Number one. What's the point?
2, 3.
2, 3. What quadrant we're going to be in?
1.
Quadrant 1. Okay. So if I have my XY axis there, my triangle, we'll say that's 2, 3 right there. Back to the origin is my hypotenuse. Vertically, straight down to the x-axis is my right angle, because I keep extend my x-axis out. Where's, did I tell you theta was always going to be? Origin. So to find all 6 trig functions, what else do I need? What was this time?
Long story.
All right. You can do push-ups when we're done.
I got off. Where's my car went start? I need to get my phone. Was that you with the beer? Oh, okay, you can. You need some salt first.
Oh, I didn't even mark you absent anyway, Miles.
Shut up.
All right, so how do I find that hypotenuse?
2 times 3.
A squared plus B squared equals C squared. So 2 squared, A squared, plus 3 squared, B squared, equals hypotenuse squared, C squared. What's 4 plus 9? 13. And take the square root, right? 4C. Any questions on that? Simple, right?
Nope. Yes.
So,
Plug her in.
remember this, correct?
Yes.
All right, so sine of theta is opposite 3 over hypotenuse square root of 13. But what do we have to do to get full credit?
Flip it.
Get this square root out of the bottom, rationalize the denominator, right? Abigail, put that away or I'm taking yours like I did Isabella's. Okay? What's the reciprocal for sine?
Cosine.
Cosecant. Thank you. All right, so just flip the original fraction. Square root of 13 over 3. Sorry, not 2. I was thinking the other one.
Is there a way to remember the flip versions?
Yeah, just remember. Okay, cosine, adjacent, A over hypotenuse, H, 2 over the square root of 13. You do the same thing, so it's going to be 2 times the square root of 13 over 13. Secant is the reciprocal of cosine. Okay. And then tangent, TOA, opposite 3. Remember our reference angle is always theta. Opposite 3 over adjacent 2. And then cotangent, reciprocal 2 over 3. There's the 6 trig functions for number 1. Number 1 you have tomorrow will be just like that, right?
That easy?
That easy.
Wow.
Okay. Simple.
Can we
Yes.
just have 5 classes?
No. You're having 14 problems exactly like the ones we're going over. All right. Number 2 is asking for a reference angle, isn't it?
Yeah.
Okay. So I gave you this angle. and you have to find its reference angle. So I always make a quick picture of it. So when we do a picture of that, remember initial side and then terminal side moves over. So that's 142 degrees. Reference angles are always between that terminal side and the x-axis. So this is what I'm looking for, that angle. So how far is it from the initial side to there? 180, right? We all know that, right? So we have to subtract 142 from 180 to get our reference angle. Okay? Reference angles are always less than 90 and always positive. Okay? No matter where you're at around your 4 quadrants. Number 3 is asking for a positive coterminal and a negative coterminal to negative 150, right? So again, I usually just, well, you don't have to draw it. All you have to do is add 360 and subtract 360 to find coterminal. And again, coterminal means that your terminal side stops at the same spot. So we know 360 degrees is one complete rotation, right? So if we were looking at the 142, I'd have to go around 360 and it would stop at the same spot. That's how I would get that one. Okay, so that's all we're doing.
So when you because wasn't there a problem when you find it and then add another 360 to it? When do you do that?
Well, it depends. If your original angle is bigger than 360, I would subtract 360 once. It's still positive. Subtract 360 again, and you should be in the negative range. If it's bigger than 720, then you subtract 360 a couple times before you get to a negative. Because, 720 is 2 360. So sometimes that might happen. If you had a negative, 400, I would add 360 twice. The first time you add 360, you'd still be negative. Then the next time you'd have a positive. So what I'm asking for is one positive coterminal and one negative. So hopefully won't be bigger than 360 or smaller than negative. But if it is, you guys can figure it out, right? Any other questions? All good questions so far today. Let's stay focused. This really isn't that hard. It's kind of long, but it's not that hard. All right, number 4. I gave you the picture of the triangle. Okay? And theta was down here. And I told you the sides were 3, 4, and 5. That's what I told you in the directions, right? So then you only had to find sine, cosine, and tangent for this one, right? So just, again, think of your SOHCAHTOA. Opposite 4 over hypotenuse 5 for sine. Cosine. Adjacent 3 over hypotenuse 5. Tangent. Opposite 4 over adjacent 3. Yeah, easy, simple, right? Number 5, you had to draw in standard position a 135 degree angle. So again, initial side, always start there. Remember we got there, that's 90. 135 is a little, or halfway to 180 after the 90. So draw an angle, draw the arrow to that spot and put 135 on it. That's all you got to do. That's a 135-degree angle in standard position. So that's a easy problem, right? Okay. Now, number 6. I gave you a picture again. Very similar to 4. But it's like number 1, you had to find all 6, right? I gave you that A was 10 and B was 5. So 10 was here, the 5 was here. I have to find C. How do I do that again? A squared plus B squared equals C squared, right? 125 is 125. And then take the square root, right? But I always tell you, on square roots, you should simplify, right? So what number can I pull out front? A 5. So the hypotenuse is 5 radical 5. When we write fractions as answers, what we're supposed to do in this quiz, right? Fractions should always be in lowest terms, right? If I had 4/8, you should make it 1/2, right? You guys all know that, correct? That's nothing new, right? Well, same thing for these. And so when I look at a picture of a triangle, I see a common factor. What is it? 5. So instead of writing my fractions and then reducing, I'm going to reduce these sides by 5. Okay? So I'll make this 5 a 1, this 10 a 2, and this 5 a 1. That way, when I write my fractions, they'll be in lowest terms. Does that make sense, what I'm talking about? Yeah. Okay? And then again, SOHCAHTOA. So sine of theta opposite over hypotenuse. When I rationalize, what's 1 times radical 5? Right, what's radical 5 times radical 5? 5. So there's my answer for sine. After I rationalized it. What's its reciprocal again? Cosecant, right? So radical 5 over 1. Cosine? 2 adjacent over hypotenuse. Rationalize it. 2 radical 5 over 5. Secant is its reciprocal. Radical 5 over 2. Tangent. Opposite 1 over adjacent 2. Cotangent. Adjacent over opposite. Again, if you didn't do what I said, if you did that 5 over 5 radical 5, and then rationalized it, you get 5 radical 5 over 25. Then you got to do what anyway? You got to do that, right? So I try to do it beforehand. That's all I was trying to show you. Questions? Those of us that were struggling on those first 6, we feel better about it now? That's the main goal. Remember, now's the time to ask the questions, right? Drake, you got a question?
No, I'm good.
All right? Because tomorrow I won't remember for some reason. You guys know that, right?
Are you screencast fine so we can watch this later?
Yes. It didn't work second period, but it worked fourth, so hopefully it's working now. Where are we at? 7?
Yeah.
So these are a couple word problems now we threw in there. A surveyor whose eye level is 10 feet above the ground determines the angle of elevation to the top of an office building to be 35.7 degrees. If the surveyor is standing 45 feet from the base of the building, What is the height of the building to the nearest foot? So the surveyor must be up on some platform or on a ladder or something. Okay? So he's 45 feet from the building. And as he looks up to the top of the building, it was a 35.7. They have these things, I forget the name of them, but you can kind of look through them and it'll tell you the angle. So he's probably got something like that. Just remember that the ground's down here, right? So let's say he's a 10-foot tall guy. His eyes are 10 feet up. Again, he's standing on something, right? So what do we got to remember after we find X?
What?
You got to add 10, right? Because the X is from here to here, right? We got to remember to add the 10 feet. You guys with me on that?
Yeah.
Okay. So I have my angle here, my point of reference. The X is which side? Opposite. The 45 is adjacent. So which trig function? Tangent. Good. So that's how we write our equation. Tangent of 35.7 equals opposite X over adjacent 45. I've been telling you to make it a proportion. How do you make it a proportion? Put it over 1. And then how do you solve proportions? Cross multiply, right? 1 times X, and then 45 times tangent of 35.7. Make sure you're in what mode? Degree. So, let me clear that out. Maybe. There we go. So I hit mode just to make sure I am in degree mode. All right, so 45, tangent, 35.7, close it up, and we get 32.33. I think it said to the nearest foot, so that we'll just say 32 feet. But again, we got to remember what? Add the 10, right? So our answer is 42 feet. The building's 42 feet high. Questions on that? Okay, the next one's about a plane going up in the air at an angle of 15 degrees, I think, wasn't it? So your angle was 15. It said the altitude was 8,000. What's the altitude? This line or this line?
That one.
The straight up and down one, right? Hunter, you got a question?
Yeah, on the last one.
Okay.
You wouldn't give us, like, say, you wouldn't give us, like, 10 inches, would you? Do we have to change it?
No.
Okay.
No, it'll be feet, I'm sure.
Oh.
Okay, so our plane got up to 8,000 feet, and it asked for the land distance it traveled. So which one's the land distance?
Bottom.
The bottom or the hypotenuse? The bottom, right? So looking at our picture, we got opposite and adjacent again, so what are we going to use again? Tangent, right? But this time the X is at a different spot, right? It's in the bottom. So when X is in the bottom, it's easier when you think about it as a proportion. Because then you remember that it's X times the tangent of 15 equals 1 times 8,000. So you got to do an extra step. What's that extra step?
Right.
Yeah, divide by tangent of 15, right? It's like 29,000 something, isn't it? So he's traveled pretty far by the time he's gotten up to 8,000 feet. Questions on those two word problems? We feel a little better about it now. if you weren't. Some of you already had it down pretty good. All right. So, some of you are getting confused on these last 6. We're at the picture of the 30, 60, 90 now, right? Let's go to another page. So, I'll just do it. Okay, so there's a picture for the next 3 problems, right? We all agree on that? Now, I told you when we first started, you should memorize this. Opposite to 30 is always the shorter leg, and I always think about it as being 1 unit. The hypotenuse is always twice as long as that. So I think of that as being a 2. The long leg, opposite to 60, is always the short leg times the square root of 3. That's always true for a 30, 60, 90. Okay? So, if this is a 20, then that's a 10, and that's 10 radical 3. Okay? If this is a 5, that's a 10, and that's 5 radical 3. So what I'm doing on the next 3 problems is I'm giving you one of these 3 sides, and you have to find the other 2. Okay? So, what is it, 9? Number 9 we're at? So I gave you, for 9, that AB was 10. And then you have to find BC and AC, right?
Yeah.
So if that's a 10, BC's half as long, so divide by 2, right? And then whatever this is, multiply by what to get AC, right? So it's 5 radical 3. So you don't have to do any figuring, really. Now, if you don't remember that stuff, it makes that problem pretty hard. I guess you could figure it out by going, if you wanted to, you could say the sine of 30 is x BC over 10 and figure it out that way. But I'm not asking for decimal answers. I'm asking for the exact answer. So with the radical is the exact answer, 5 radical 3 instead of whatever that is. Questions on number 9?
I get that, for sure.
All right. Autumn, question?
No,
Okay.
just keep going, I'll figure it out.
Number 10, I gave you AC as 2 radical 2, which is this one. So remember, if I go, and then I'm looking for BC and AB, right? So if I'm going from BC to AC, I multiply by the radical 3. So what do I do if I go the other way?
Divide by the radical.
Divide by the radical. So that's the way I'm going, right? Does that make sense? So it's this, AC, divided by radical 3. Am I allowed to leave it like that? No, I have to rationalize it, right? So what's radical 2 times radical 3? No?
6.
6, yeah, multiply.
Oh, I guess I don't get this.
I'm multiplying 2 times 3, right? So what do I do from the short leg to get to the hypotenuse? Always times 2. So what's this times 2? 4 radical 6 over the only thing you multiply by 2 is that 2 in the top.
Can you go to BC again?
Going from AC to BC, from the long leg to the short leg, you always divide by radical 3.
But couldn't it just be 2?
Yeah, why would?
Why wouldn't it just be 2? Because it's 2.
I'm going from this one to that one. So you always divide this number by radical 3 to get that one. Then you always take this one and multiply by 2 to get that
Radical 2 and radical 3 don't cancel each other out.
No.
They're 2 different numbers.
Oh. Alright, so that was radical 2.
one. Yeah, if it was radical 3, you're right. It would have been 2. I give you AC again. I should have given you BC, actually. I think that's what I wanted to do, but I didn't. So now it's 5 radical 5 for AC. So we're doing the same steps. So to get BC, what do I do with that number? Divide by radical 3. And rationalize it. So it's 5 radical what? 15 over 3. And then AB, what do I do with that 5? Just multiply it by 2. So basically, 10 and 11 are the same problem. I just changed what you started with. The same procedure.
So can you do it for BC now?
I can.
Oh, looks like I'm missing 2 points. Oh. What?
All right, so let's say I gave you that one. What's this one?
Radical 3.
What do I multiply that by? So Timmy, you are correct. What's that equal? 3. What's the hypotenuse? 2 radical 3 times 2, right?
Oh, I had, oh, that's messed up. Oh, I was never good at these last 2.
Well,
You did?
yeah, it's all review. You guys are whining.
No, we went to cosine, sine, and tangent. We didn't go into this.
Oh,
Oh,
we
we
did.
did this? Did we do this during quarantine?
I say move it back.
No, Mrs.
All right, so
Like the original template.
Abigail, what's the hypotenuse? Yeah. What's this one?
7 radical 3.
Yes.
Let's go, Joey. But I don't know how to go opposite of that. And if it's
Wait, I
radical.
don't even know how to.
Then you need to study a little bit more.
I mean, yeah.
It's like all that.
All right, the last 3. We'll get a nice looking.
Come on now.
That's what sharp.
Oh, okay.
Why do you always draw your triangles that way?
I don't know, that's just how I am. Weird, I'm just weird. So for the last 3, this is our picture. X is up here, Y is here, and Z is here. What do you know about YZ and XY? They're the same. So I always just make them ones. And then what was the relationship between the leg and hypotenuse? Multiply by the square root of 2, yes. Always. That's the relationship for a isosceles right triangle. Always true. Okay? So, number 12, I gave you XY is 12. So this is a 12. So what's this one? 12. What's this one? Which one am I asking you for? XZ, right? So that's our answer. Okay? All right, the next one. $13. I gave you XZ is 14. So now this is 14. So how do I go from here to get over there? Yeah.
So it's 14 radical 2. Oh, no. Oh, then you.
Right?
Yeah.
Is that what I'm looking for, XY? Yeah.
14 radical 2 over 14.
All right. So I have to do this, which is 14 radical 2 over 2. So what's the answer?
14 radical 2 over 2. Oh.
Yeah. 14 divided by 2 is 7. So you got to simplify it all the way. Abigail?
If we put 14 on 2 over 2, it's telling a girl.
Yes. Because it's not simplified all the way.
Oh, when you simplify to divide the single number. Okay.
Yeah.
Connor, oh my God. Oh my God. Oh,
We got one more. All right. We good with that one? Any other questions?
Ooh, I don't know. It's that one.
Last one. I gave you YZ is 5 radical 5. Where's YZ? That's this one, right? And what am I asking you for? The hypotenuse, right? So what do you always do to a leg? Multiply by radical 2, right?
5 radical 2.
That's it.
What?
Simple.
I don't think I'm bigger.
That's how you roll, Sully. A little bit tough.
I've never not. It's always been.
Are you sure about that,
I
Sully?
swear, it's always coincidental.